This tutorial is about the Production Injection Data tab in Wellbore Simulator. When we click on this tab, you will see this form appear. The Production Injection Data tab is used to supply the information regarding the injection points or production points in a wellbore configuration. For steam circulation, we could have an injection point in one pipe and a production point in another pipe. For a steam injection scenario, we could have two injection points. We could have one injection point in one pipe and an injection point in another pipe. For a production well, we could have production points specified at the wellhead. And if we have gas lift injection in the production well, we could also add in injection points at the gas lift tubes. Sometimes you can even have two or more injection points in a given pipe. To identify which pipe or segment, we have this form here, and we have a uniquely identified point number, point 1, point 2, point 3, point 4. For each point, we identify which pipe number and which segment. So if you go back to, say, in this circulation data case, if we go back to, say, the pipe data, we will see, if I look at this pipe schematic, or if you look at the pipe data, you will see pipe 1, pipe 2, pipe 3. In this case, a circulation set, and 2 and 3 are the two tubings that we're going to circulate in. So we're going to inject down the long tubing and produce back up the short tubing. So for this configuration, we would have a injection point at pipe number 2, the very first segment 1, and a production point in pipe number 3 in the very first segment 1. So for each point, we have a point flow coefficient. If I were to bring up the formula for calculating the rate into each point, we have this formula. The rate of injection is calculated using this point flow coefficient, the WI, the injection pressure, so we're going to specify an injection pressure here. MPI here is the wellbore segment point pressure. This is the segment pressure itself, so this injection pressure is an external pressure outside the segment. This point flow coefficient relates the external injection pressure to whatever is calculated inside the segment pressure. So we don't have an exact rule for saying how large or how small this number should be. All we can say is that if once we fix this point flow coefficient for a given rate Q, for a small point flow coefficient, we would have a larger pressure difference between the external pressure and the segment pressure. Once we fix this rate Q for a large point flow coefficient, we would have a small difference between the external pressure and the wellbore segment pressure. So all we can say is that once we make a run using a point flow coefficient, if you look at the results of the run, and for this case here, for example, if you look at the tubing pressures and look at the rates pressure of the tubing, for tubing 2 we have specified an injection pressure of 3000, and the actual tubing pressure was 2999.969, and if this difference in pressures is acceptable to us, then this is a reasonable point flow coefficient to use. Too high a point flow coefficient, we have a very small difference and we could have instability problems. Too small a point flow coefficient, we can have a pressure that's too low in the tubing, different than our injection pressure, and that may not be acceptable to us. Similarly, for the production point, this is a production point in the pipe 3. We have a point flow coefficient of 100 and offset pressure 1200, and this 1200 versus the actual pressure, production pressure point was 1202. So we have a 2 kPa difference, and this is reasonably acceptable to us. So for of the point flow coefficient, we put in an offset pressure and injection pressure. So offset pressure is for production points, injection pressure is for injection points. For this injection point, we also have the capabilities to specify maximum injection water rate, maximum injection gas rate, steam rate, and this is the maximum rate. For the offtake points, we don't have a similar entry, because for offtake points, what comes into from the reservoir must come out must come out at offtake points. So the only thing we can specify is the offtake pressure. Now the injection points specify a maximum injection rates of water, gas, or steam. So the program can either meet one of two constraints. It can either meet the maximum injection rate constraint, or it can meet the maximum pressure constraints. If we look back at the results of this run, we can see that the program has met the injection rate constraint of injection pressure constraint of 3000, and the injection rate constraint was 181 millicubes of cold water equivalent steam, though we have specified a 300 millicubes per day of steam, cold water equivalent. So in this case here, the program has prorated the maximum steam injection rate and met the maximum injection pressure. For the case of a heat injection well, it is also possible to specify a heat transfer coefficient, much like the point flow coefficient. The injection temperature tells us what is the enthalpy, the injection temperature of the fluids, and for production point is 0. For injection point, we put in the injection temperature, so we can get enthalpy of injected gas or steam or water. Be aware that when the program reports the temperature, for example, when it reports the temperature here, this temperature in the tubing is 2133, but we've injected at a temperature 223. But because this is at steam conditions, this temperature and pressure are related by the steam curve, steam saturation curve. So even though we get a different calculated temperature, it's because that we're injecting fluids at that enthalpy calculated at that temperature. And the steam injection quality, this is the injected quality of the steam. And if you look at the steam quality is 85, injected in here 85. This is the composition of the injected stream, and for water is a cold water equivalent. The mole fraction of the injection stream is 100% water, and for a gas stream it would be say the gas component. For production stream, we do not specify any of the mole fractions. For superheated steam, this would be, instead of steam quality, we will put a superheated pressure, and next time we look at this number, for example, we put in 2000, for example, as a superheated pressure, and we go back to reservoir data and back to this, we would see this is a superheated pressure now. Thank you. This is the end of this tutorial.